Hello grade 8s, this is Mr. Miller and welcome to lesson 7.4 on solving problems involving prisms and cylinders. So in number 1 we're looking to fit 4 centimeter cubes into this box here. So by 4 centimeter cubes, let me just clarify what they mean here. They mean cubes that are, and sorry I haven't drawn this perfectly here, but what they mean is something that is 4 centimeters by 4 centimeters by 4 centimeters. So first of all, the number of cubes that can fit along the length, and we're talking about the length here, so obviously 32 divided by 4 would be 8. And the number of cubes that will fit in the base, so there would be 3 that would fit across this way, so 8 times 3 would give you 24. And how high could you stack them? Well, since this is 8 centimeters tall, you could fit 2 stacks. And so the number of cubes total would be 24 times 2, and that would be 48 of them. Next question, will they fit perfectly, leaving no extra space? And the answer is yes. So the explanation for that is that they will fit perfectly because 4 can be divided into each dimension. So each dimension of the box. So that is to say that 4 went into 8, it went into 32, and it also went into 12. If it didn't divide perfectly into those, then there would be some little bit of extra room left over. So next question, we're being asked to find the volume of this shape. And this is an interesting problem here because you could look at this as having to do 3 separate blocks. You could cut off right here and find volume number 1, volume number 2, volume number 3, and add them together. You certainly could do that, but why make life that complicated? Instead, you can recognize that all you'd have to do is shift this down creates a single rectangular prism. Of exactly the same volume. And it's a lot easier to figure out its volume. So you can simply do length times width times height. So, and you can see that the length is 16 and the width across is 6 plus 6 plus 6, that's 18 centimeters. So now, I mean, I could have called that length, it doesn't really matter. And the height of this thing is 12. So multiplying those 3 numbers together will yield the following result. 3,456 cubic centimeters. Next, number 3, it says to find the volume of this shape with a triangular hole through it. And so the strategy that you can use here is that you can take the volume of the cylinder and subtract the volume of the triangular prism that is the hole being cut out of it. So we can do pi times r squared times h to find the volume of the cylinder and subtract the volume of the triangular prism. So to find the volume of the triangular prism, you find the area of the triangle and you multiply by its height. So you have to do the base of the triangle times the height of the triangle divided by 2. That will give you the area of the triangle. And multiply by the height of the prism. So for pi, we've been using 3.14. The radius of this, since the diameter is 15, the radius is 7.5. And the height of the cylinder is 35, because it's the distance between the two circles on either end. Now we subtract the base of the triangle, which is 3, times the height of the triangle, which is also 3, divide that by 2, and multiply by the height of the prism, which is also 35 centimeters. And so when you multiply this through, then that gives you approximately 6,024.38 cubic centimeters, rounded to 2 decimal places. Next, it says we've got a box that has a base of 20 centimeters and a base that is 20 by 20. You want to fit cans with a diameter of 6.6 centimeters in the box. The height of the box is 10.2 centimeters and the height of each can is 10 centimeters. And we want to draw a diagram to show how many cans fit in the box. So just note here that the distance between dots represents 2 centimeters. Okay. So now, I guess the first thing we want to do here is we want to draw the box. And so I'm going to do that. So I'm going to start somewhere near the middle, and I'm going to go in this direction. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then I'm going to go across this way. I'm going to go, oops, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm just starting off by drawing the top of the box. So again, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And finishing it off from here to there. Now the height of the box is supposed to be 10.2 centimeters. So 2, 4, 6, 8, 10.2 is just a little bit more than that. Now I can copy and paste that, and I'm going to move that over here, this piece, and one more piece over there, And now I'm going to draw bottom edges here and also here. Okay, so we have our box, and I'll just indicate the measurements here. So this is 20 centimeters this way, and it's 20 centimeters this way. And the height is 10.2 centimeters that way. So now we'd like to fit some cans inside. And the cans are supposed to have a diameter of 6.6 centimeters. So let's see if we can start to fit those in. So first of all, what I'm going to do is I'm going to create some guiding lines to help me to draw these shapes. So I'm going to go 2, 4, 6, and a little bit. Two, 4, 6, and a little bit more. And this sort of splits it up into roughly thirds. 2, 4, 6, and a little bit. Gives enough room for the diameter of the pop can. 2, 4, 6, and a little bit. There we go. This just gives me a framework to work within. And now I can draw some oval shapes to indicate the tops of the pop cans. So what I would do is I would go from the middles of these edges, and that gives me the top of the pop can. Then I'm just going to repeat this shape over and over again. And so that takes care of that. And of course it should go down to the base. So now this just gives the illusion that I've got all these pop cans here. All nicely done in 3D. And now that I've got that all set up, I can take away these guiding lines. And there we go. You can see that here I've got myself set up with 1, 2, 3, 4, 5, 6, 7, 8, and 9 cans. And so, yeah, as was indicated, the diameter of these is 6.6, and the height of them is 10, so they fit in with just a little bit of room to spare inside this box. So now we do a few calculations here. We want to calculate the volume of the box. So we'll do that first. I guess I should do that in blue since the box was done in blue. So the volume of the box, since this was a rectangular prism, we simply do length times width times height. So we do 20 times 20 times 10.2, and if you multiply those three factors, it'll give you 4,080 cubic centimeters. The volume of a single can, and I guess I should do that in green, just staying consistent here. The volume of a can is going to be pi r squared times height. So this is approximately 3.14 times. The radius of a can is going to be 3.3 since the diameter is 6.6. Square that, multiply by the height, which is 10. And multiplying those factors, you'd get 341.946 cubic centimeters. Now, dividing the volume of the box by the volume of the can will give you, so volume of the box divided by the volume of a single can, which is your 4,080 divided by 341.946, and we get 11.93, approximately speaking. So this kind of indicates that there would be close to 12 cans that could fit inside this volume, not just 9. So to give an explanation for this, here's what I would say. I'm going to switch to typing because that'll go just a wee bit faster. So in each dimension, so this is length, width, and height, there is some extra room that we can't fit another can into. Plus, there is extra space between the cans. So while the capacity of the box could fit the contents of, sorry, I just want to stay on the page here. nearly 12 cans. Only 9 cans can be packed into this box. So there you have it. Shift this over a little bit so that it's a little bit easier to read. And for this, we'll just choose a different color, maybe purple. Have it stand out a little bit. That's the end of the lesson. So thanks for watching this video, and have a great day.